Thank you so much, Jan, for that very long introduction. No idea what he said. Was it good? Something about a laser? That's usually how it goes. Yes, well, I'm so pleased to be here. What a great night. What a great building. I'm really pleased. Right, so I'm Seb Lee-Delisle. I'm an artist who makes things with code, or you could say that I'm a programmer who programs arty stuff. But really, there's one thing throughout all of my work. Every single thing is made with code. So here's a classic example of the sort of thing I'm talking about, which is the Get Enough spoon, which was a collaboration with an inventor artist called Dominic Wilcox. And I programmed and did the prototyping for all the electronics in this spoon. And so all the eye animation and how the lights work and all of that stuff, that was all done with code, right? And it's sort of the same stuff as Val was talking about earlier, saying how the animation can instill a character into inanimate objects. And just in the same way, with my programming, I made this little spoon, and he falls asleep when he's run out of energy, and when he's eaten all his cornflakes, he's like totally wired. You know, so you can do really cool animation and make characters with code. So I'm going to show you a few of my projects to start off with. The first one is called Laser Light Synths. So I wanted to make a project. I used to be in a band, right? Who's in a band? Yeah, a few people, Mark Thiele, obviously. But whoever wanted to be in a band? Yeah, whoever wanted to learn a musical instrument? Yeah, quite a lot of people, right? Why didn't you? It's really hard, right? It's really difficult. There's a lot of wrong notes. And it's sort of technically difficult. So I thought I'd make this massive installation with 4 of these musical instruments that are covered in super bright LEDs, and they're touch sensitive, and they're easy. They're for anyone to play. You can see here I'm making them. You can see all the LEDs there wired up. And there's those copper tracks. That's the touch sensitive surface. So I took out all the wrong notes, locked it into time, and so anyone who comes up to one of these instruments can just be the band for one night. And obviously, because I like lasers, you might have heard, I don't know, I put lasers up the building while you're playing it. So as you play a note, it makes a laser particle up the column. She was so good, that little girl there. She was playing the bass. At one point, I said, OK, bass solo. I didn't know it was like a 3-year-old girl. I couldn't see where I was. Bass solo, and there's this amazing bass solo that came out. It was only later I looked at the footage. It was this tiny, tiny little girl. It was absolutely amazing. Yeah, so totally lost my thread now. Anyway, yeah, so a musical instrument that anyone can play, lasers that produce visualizations depending on what you play. Yeah, so that's kind of a fun project. I do a lot of stuff outdoors on a big scale. So I've got these interactive digital fireworks. It's called Pixel Pyros. In this case, I bring my own screen. It's 20 meters wide, 20 by 12, and we rig it up on these scissor lifts, like lots of heavy plant and crew. Oh, it looks so cool, doesn't it, that? So that's quite cool, because the screen can just be raised and lowered in a couple of minutes. So what happens is I project bright spots of light along the bottom of the screen, and as you wave your arms in front of them, it triggers the fireworks. So unlike ordinary fireworks displays, where you're not allowed to really play with the fire, right? That's generally not allowed. But here, you can get up and trigger all the fireworks. So for this project, I use massive projectors, but I also add a laser, right? So this was the first time I'd really worked with lasers. And they're so cool because the projectors sort of fill the whole space, but the lasers can just pick out these really bright spots and actually look like it's glowing, a bit more like real fireworks. But of course, because these are digital fireworks, it's kind of fun and nice to make fireworks that you couldn't make with real chemicals and explosions. So I made all these different styles. Some of them were more sort of neon style, like Tron. Some of them were like low resolution. And of course, some of them were like more traditional fireworks. Did you see the laser? No? It's quite cool. Wait till the fireworks show, and I'll point out some of the laser bits. Oh, very excited. He was very excited about it. Yeah, so these are just the starter fireworks for, sort of fairly normal looking ones. These ones are like Tron. Can you see the really bright lines like there? That's the laser. Oh, I love the lasers so much. It's so cool. I've just been getting bigger and bigger lasers and more lasers. It's honestly a bit of a problem. So the great thing, and there's the low resolution, 8-bit, old-fashioned style of fireworks. So that's what fireworks would look like on, a Commodore 64 or something like that. So also with all of my projects, I like to put in games, right? So I thought, well, why not just make Space Invaders, yeah? So there's Space Invaders with like 30 people all firing at once. I didn't even put scores in. You couldn't die. It's not a real game, and yet still everyone loves it. Asteroids as well. I'm going to be talking about asteroids later. You know the game Asteroids? Yeah, from 1979? I'd like to say that was before I was born, but I can't. OK, so that's Pixel Pyros. So this was 2013 when I learned to work with lasers, and I thought I'm just going to put lasers on everything. So I was asked by Smashing Conference to do an intro for their conference. This was in Oxford in the UK, where I'm from. And because I'd just learned about lasers, I was like, yeah, I'll do your intro, but I want to do lasers. And they're like, sure, whatever, Seb, just do something. I'll be like, lasers? And they're like, whatever, I don't care. Lasers. OK, so now, you might have been to conferences, and there's often a nice introductory animation at that. But anyway, I saw this venue. It's the Oxford Town Hall. And I just saw that architecture and the pipe organ. And I thought, really, I've got to do something with that architecture. I can't just do any old laser stuff. I'm going to have to really figure out how to work with that. So what I did to start off with, I actually worked with Val. Like the first speaker tonight, we worked together, and Val did all of the animations that were on the screen. So we started off, and it was just, all this animation is programmed, by the way, in C++. We thought, yeah, nice animation. So people in the audience thought it was just an animation on the projector. But then a little way through, we decided to break out of the screen and into the whole building. That's the laser there, right? So that's one laser. You know what? My wire's getting really tangled up. I'm just getting, hang on, excuse me a moment. Oh, that's fine. I thought I'll be really professional and put it through under my shirt, and now I'm just like totally tangled up. Anyway, so I thought, really, with that pipe organ, I'm going to have to turn it into a graphic equalizer, right? There's just no choice there. And I thought, in the end, I ended up modeling that whole entire dome in software, so that when I made the laser go on it, I could make it look like the laser was literally wrapping around that space. You'll see that in a minute. Here it comes. So I can actually use the space, right? I can use the space itself to make it look like the lasers are kind of all over it. And it goes around there as well. That's pretty cool. Honestly, I've come to this building here today, and I'm just thinking, oh, right. Yeah, maybe next time. Bring the big laser. Yeah. OK. Oh, well, only in the dark, but I expect it's going to be worse. Is it going to be like more lasers required? OK. All right, next time. OK, so you might have noticed, like Val already mentioned particles today, right? Who likes particles? Yeah, Val likes particles. Tom London, the magician, likes particles, right? Yeah, so you might have noticed in all of these projects that I've just mentioned, there's been a lot of particles. Did you notice? You probably don't even know what I'm talking about. So a little bit, maybe. So particles are a really cool, creative coding technique. Oh, thank you very much. Oh, it's not you. OK. It's coming from the speakers. OK. Particles are a great coding technique, especially when it comes to artistic, creative programming, because the core code is really, really simple, and yet the outcome can be very sophisticated. So I thought I'd do a bit of programming for you today, just like Val did some programming. I can do some programming, too. I'm going to do some programming in JavaScript. I feel really small behind this. I could get like some bricks or something. I'll just stay on tiptoes. Oh, this is what it's like to be normal height. OK. Actually, I can't type when I'll stay down here. Just be short. It's fine. Anyway, so JavaScript is quite cool. That's really in my eye line, that one. Hang on. There you go. That's better. JavaScript is really cool in HTML5 because a few years ago they brought out Canvas, which meant that anyone who wanted to do graphical programming could do it in Canvas. Who's programmed in Canvas here? We've got some programmers, haven't we? Yeah, half of you have. OK, cool. So Canvas is quite cool. It just is an image that you can draw stuff into. So I've made a canvas here, so I've started a little bit. I've got a little bit of HTML. It's not that much. It's not really cheating, is it? OK, so let's draw something. Let's draw a shape, yeah? Any shape. What shape shall I draw? Triangle, yeah? Anything else? Hexagon, yeah, that's good. Some good shapes. Any other shapes? Triangle. What was that? Evil triangle. Oh, that's quite good. Did I hear rectangle? Yeah. OK, rectangle. OK, let's have a look. Well, to draw a rectangle, you can just type fill rect, and you can put in the coordinates, the x and y position of the top left of the rectangle. So I can do it in the top left, and then the width and the height of the rectangle, 100 by 100, and you can do that. But unfortunately, the default color is black. So let's set the style. So any color you like. Purple. I heard purple. Let's just do purple. So this is the same as CSS colors, right? So I can put in any color that you get in CSS. And there you go. A purple square. Yay, that's our particle. Yeah, it's our first particle. Does it look angry? No, not yet. It looks a bit boring. OK, that's because it's not moving. So how do you actually get things moving in JavaScript? Well, there's a fancy modern way of doing it with request animation frame. I'm going to do it the old school way with set interval. So set interval will just call a function called, well, in this case, called loop, every 16 milliseconds, which is roughly 60 frames a second. So now this purple square is being drawn 60 times a second. Yeah, right, OK. In the same place. OK, so let's make a variable. Actually, who isn't a programmer here? OK, a few but hopefully hopefully you kind of get it. Who's just done a tiny bit of programming? OK, that's fine. That was a stupid question. Like one person, I've done a weekend course. No, I don't know. OK, let's make a variable called x. Let's store 0 in it. Let's draw the rectangle at x every frame, and then add 1 to x every frame. Oh, OK, so this is where we learn that the canvas is persistent, right? So once you draw something into a canvas, that's it. The pixels are changed forever. So in order to actually make animation, we need to clear the entire screen first. And we're going to go 0, 0. I don't know how wide it is. Let's just do canvas.width, canvas.height. It's really hard typing in front of people. Have you tried it? It's like, when you're working and your boss stands behind you. It's like, yeah. Imagine that times about 300. So if I mess up, please shout out, right? Anyway. Here we have, yay, a moving rectangle. Oh, that guy. Thank you. There's one guy there. It's like, one guy. Oh, so no, it gets better. Wait till it gets good, and then you can go wild when it goes good. OK. Right, so let's make some more variables. In fact, because you're quite an advanced audience, oh, no, I'm going to have to build it up a little bit, actually. Right, let's make an x and a y variable. And then we can have our square move in both directions. There you go, like that. And we can also set how fast it goes with an x speed. Let's do x speed, I don't know, 2. Y speed, oh, can't type, equals 4. I don't even know what I'm typing anymore. So then here, instead of just adding 1 to x, we add x speed to x. And here we add y speed to y. So now you'll see that the square's moving sort of fast and to the right. But I could make it just move down. Like, well, let's just set the speed to 0. And then what do you get? It doesn't move at all. We can set the x speed to 5. Moves to the right. 15. Even faster. -1, what's going to happen? Yeah, someone's like, disco dancing. OK. Right, so yeah, it goes to the left. So we can do that with x and y speed. So instead, let's make random x and y speed. And you can see I've made a random function there, so that makes it a bit easier. So I can say x speed equals a random number between -5 and 5, and y speed equals a random number, the same, -5 and 5. So now whenever I run it, the square should go in a different direction, right? Let's just move the square into the middle. Right, so at the moment it's in the top left. Let's do canvas width divided by 2, canvas. So that's basically halfway along the canvas width and height. So it should start in the middle. So now every time I run it, the rectangle is going to go in a random different direction. Oh, it wasn't ever going left. I thought, oh, have I made a bug? But no, it does go left. Yeah. All right, excellent. OK, so now this is quite a big particle, isn't it? Like, really, particles are smaller. Let's just make it a bit smaller. And of course, like, one particle is, oh, that's cute, isn't it? Yeah? It's not even doing it. Look. It's really small. I've clearly lost my mind. OK. So one particle, I'm sure you're aware, is pretty damn exciting, right? But particles only really make sense when there's a whole load of them. So in order to make a whole load of them, well, first of all, let's wrap up all these variables into a single object. I feel really short. There you go. I was in Holland last week. They're tall, aren't they? Dutch people, they're very tall. I was just talking to people's chests the whole time. It was really weird. Anyway, OK, so let's make a particle. I don't know what I'm talking about. Let's make a particle object called P, and we're going to wrap up all these variables into this one object, like that. So now we don't have to, we don't have to, like, we don't have to access those variables individually. Now they belong to my particle object P. You might wonder why I'm doing all this work, right? Because at the end of it, after the end, I've typed all these P's. We end up with basically exactly the same thing. Yeah, but now we've got an object. It's all wrapped up, which means that now we can have a load of objects, and we can put them in an array. Yeah, so let's make an array. If you don't know what an array is, it's just something you can put a load of stuff in. That's the technical definition. Yep. So maybe I could be like Val, and maybe I should write a book. Array is something you put stuff in. All right, maybe not. OK. So now, instead of making the particle at the beginning just once, I'm going to make the particle every single time. 60 times a second, I'm going to make a new particle. And then I'm going to add it. I'm going to push it into the end of the particles array. So every frame, the particles array is going to get longer. And here, instead of just drawing one particle, I'm going to iterate through with a loop, and I really can't type now. It's really hard. It's on this lectern as well. It's hard, wasn't it, Val? Yeah, it's pretty hard. Particle, I'm just making excuses for when it doesn't work. Right. OK, so I make a for loop. So that's going to go round and round as many times as there are particles. And then at the very beginning of that, oh, did you see that? It disappeared. And then it came back magically. I'm a bit worried. TextMate has been a bit buggy lately. OK, anyway. Then I pull out the particle from the array at index I, and we've got So for those of you that have seen me talk before, I do this quite a lot. So it's like, oh, here's just something I just imagined. No, I have done this a few times. But particles are cool. It's such a good demonstration. We can do so much with it. We can even add some gravity, right? So we can just make the y speed, add a little bit to it every frame. Whoa, now they fall down, right? So then we could actually just make it bounce, right? Bouncing is one of the principles of animation. I was paying attention, Val. Which principle is it? Bouncing? That's what it's called, yeah. All right, let's make it. Which number is it? She doesn't know. OK, is it in your book? You should get Val's book. It's really cool. Nearly as big as a small dog. OK. If the y position is greater than canvas height minus 100, so if it's 100 pixels off the bottom, then we're just going to reverse the y speed. How do you do that? A mathsy way is just by multiplying it by -1. Whoa. Yeah, so particles, you can do so much with it. And I've got some, here's one I made earlier. So I've got this code here. Oh, where is it? Hang on. I've got a folder especially for it. This one, particles best ever. Let's just try that one. Look at that. Yeah, so this is basically the same code that you just saw, right? But there's a bit of drag on there. They're sort of blended together when I draw them, so they're additive blended. And yeah, and that's kind of all there is to it. It's kind of pretty cool, isn't it? And then here in this example, similar sort of system, but in this case, I'm comparing the position of every particle with every other particle, and if they're too close, then I just push them apart a little bit. That's all it is, just like, it's overlapping. Let's just push them that way a bit. And then they look like they're colliding with each other. And how they're colliding with the bottom, that was basically the same code that I just showed you, except it doesn't check if it's too far left or right. So you can see, you can get some pretty cool effects just with, I don't know, how much code is that? It's like one screen full? It's just one screen full. Yeah, that's pretty cool. OK, so oh my God. So the clever people among you might notice that there's a slight memory leak in this, right? Because it's just continuing to make particles forever and ever. Obviously, you can fix that in your own time. That's an exercise for the audience. OK, so let's get on with the presentation. Oh, there you go. Look. Made by Seb and Val. Yay. All right, code time. OK, we did that. We did code time. Oh, I can't see my screen. I was like, I want to see my screen, and I'm not very professional. Anyway, retro. I really love retro gear. I love retro computing. You know, I grew up with old computers. This was probably the first computer that I programmed on, the Commodore PET. What does it say? 32K of RAM? I think that's pretty exciting. You can get a lot of particles in 32K. This is how computers used to boot up. They were kind of aggressive. They were like the angry triangle. They're just like, what? What do you want? I don't know, I just want to program. So you'd learn to program in the 80s. This is how you'd learn to program. There's a TV show with this really inspiring old man. I'm probably that age now. That's scary, isn't it? I better get my sweater and tie. Anyway, the BBC Micro, classic British computer. But that was obviously the Commodore 64 as well. But everyone was really excited about computers in those days, right? Really excited. We all wanted to learn to program. This guy is really excited. Oh, my God. But then, do you blame him? Because he's got the Atari 2600 console with cartridge swapper. Look at that. He didn't even have to face the unnecessary complexity of pulling out a cartridge and putting another one in. He had this wonderful device. Look at that. That's some product design there, isn't it? That'll do. But look how excited he is. That's retro gear is like that. Now, I pulled apart an Atari 2600 joystick. This is from 1979. Look at the circuit board on that. Right? That was hand-drawn, most likely. That was hand-designed. You don't see many hand-designed circuits anymore. First thing I did, of course, was put in a Pro trinket, an Arduino-type electronics board, so that I could plug it into USB. Right, so I've got this joystick. I can play all my games on it. That's pretty cool. There are lots of other really innovative technologies in the 80s. This is one of my favorites, the Casio VL1. Who had one of those? Was that a big thing? Yeah, one guy did. Pretty spectacular. It was like the whole band in the palm of your hand. Look at all these amazing instruments. 5 different instruments. Oh, what do we have? It doesn't even say. On loads of drum beats from rock to rumba. Even more amazing, it has a calculator. Right? Because it's not enough to have a musical keyboard. You've got to have a calculator as well. I love this musical instrument. Absolutely wonderful. Then there's also cathode ray tubes, right? These are old-fashioned TVs. You don't really see those anymore. They used to be so cool in the 80s. Be so many. The more cathode ray tubes you could find, the better. We'd all be just irradiating ourselves in front of the TV. Oh, it was good times. But this is where you'll see cathode ray tubes now. Pretty sad, right? Yes, it's tragic. There's lots of them dying. Cathode ray tubes' natural habitat was the arcade machine. I love all those. You could probably tell, right, from the Space Invaders and Asteroids. I loved these old arcades. And they all had cathode ray tubes. They were often mounted vertically, so you'd have a vertical screen. It's pretty cool. This is how a cathode ray tube works. I bet you wanted to know. Yeah, do you want to know? One person wants to know. That's good enough for me. OK, so we've got an electron beam. We've got an emitter coming out of here, just firing out electrons, just going out here, just randomly. Then all these magnetic coils, they're powered up. They force all the electrons into a single beam. So just going like a kind of laser beam, right? But they're electrons, and they're just firing in a tiny beam. And then they hit this. This is a massive glass front to the screen with phosphor on the inside. And when the electron beam hits the phosphor, it glows up really super bright and beautifully. So these coils would change how much power, how much magnetism they had to move this electron beam around. So obviously the cathode ray tubes, the TVs that we used to have, the electron beam would move from the top left to the right in a single line and then turn off and move all the way back there and do the next one. And as it was drawing that line, it would get brighter and darker. So over time, it would create that whole picture of a TV. So a lot of TVs had these scanning cathode ray tubes, but some monitors had a different type of cathode ray tube, like this oscilloscope. In this case, the cathode ray is just drawing that shape. Right? It's just moving along and drawing the shape, and it's making a line. That's pretty cool. And some of the old arcade games had a screen like this. So instead of using like scan lines, it would literally draw the shape. So the cathode ray would start there, and it would move down there, draw that line, then it would draw there, and it would do it so fast that it just looked like a whole image. Quite a few games had that, including Lunar Lander, which I love. I did a project with Lunar Lander once. Great, great game. Star Wars, the early Star Wars games had that. Look how beautiful those graphics are. Look how sharp. And, well, unfortunately, it's quite a low-resolution photograph. But look how beautiful and bright those are. Oh, this is Tempest. Anyone play that? Yeah? No? You're all too young. And you could bring home a vector monitor in this console. This console is called the Vectrex, and it came with a vector monitor. You can see the very distinctive style of graphics there. But I want to talk about asteroids, because I love asteroids. And this is an original asteroids machine, and I don't know if you can see. Can you see the quality of that screen? Just look at the bullets. Look how bright the bullets are, because the cathode ray just lingers there a bit longer, so it just makes these really bright bullets, really beautiful. And so you can play most retro arcade games these days with MAME and other emulators. But unfortunately, you can't quite recreate that screen. Like here is Asteroids on MAME emulator. So you don't want to see that, do you? Look at that. Look at the bullets. It's rubbish. It's pixels. You don't want to see pixels in Asteroids. Look at that. Oh. So cool, right? Ugh, just disgusting. Yeah. Right, so I thought, well, so I use lasers quite a lot. And I thought, well, the way that a laser works is kind of the same way that this cathode ray works. So with my lasers, I've got a couple of little mirrors, one laser beam, right, and a couple of mirrors that's just moving. One of them makes the laser beam go left and right, and one of them makes the laser beam go up and down. With those two mirrors, I can move them around really fast and draw a shape. So I thought maybe if I made asteroids with a laser, then that would be really fun. There's a guy there just like... And so you probably should do that, because otherwise you might get blinded by my laser. Unfortunately, I didn't bring my laser. You might have heard. Next time, I'll bring all the lasers. Yeah. But I did make asteroids with laser. You can see it here. I'm just running it in my studio at home. And this is like daylight, right? This is daylight in my studio at home. You see how bright that laser, oh, that's my new laser there. That's quite a cool one. You see how bright that is. It just even totally burns out the camera. So unfortunately, I can't really show you that in real life. But we'll come back to asteroids later. But for now, I just wanted to show you, just turn mirroring off. I just wanted to show you the code that I use to run asteroids. It might be a little bit small on this screen. OK, here we are. So this is all my laser control code on here. And you can see that, oh, here's asteroids, right? So this is the code that I use to control my laser. And you can see these blue lines. The blue lines determine where the laser goes when it's not switched on, right? So if I want to draw two separate shapes, I need to turn the laser off, move it to the next point, and draw asteroids again. So I could just have a little game of asteroids. I should have brought my joystick, shouldn't I? Whee, that's pretty. So this looks really cool on a laser. Oh, damn it, I did. So I made asteroids with a laser, and I thought, maybe there'd be a modern game, a modern arcade game that would benefit from being rendered with a laser. So I thought, what about Flappy Bird? Let me just turn off the laser path. So this is Flappy Bird. Now, Flappy Bird is... it's a really difficult game, right? And I could just sit here and play Flappy Bird, but it wouldn't be very interesting for you. Like, this version of Flappy Bird is played by everyone here in the audience today. So maybe, I don't know if you can see it, it doesn't seem to be working rather worryingly. Let's just turn this up. Oh, there you go. Right, so you can probably tell that the sound of my voice is making that bird fly up and down. I can't really make it go up very high because I'm not really loud enough. So this is a version of Flappy Bird where you play the game by applauding, by clapping, right? So the louder you clap, the higher the bird flies. Why don't you give it a try? Oh. OK, are you ready to play? Are you ready to play for real? Yeah? Laser clappy bird in 3, 2, 1, go. Yeah. Who whistled? What did you say? Who was it? Yeah, who was it? Do you want to try again? Yeah? OK, go. Oh. You know what? That was like the best ever score I've ever had. I've never, like, usually it's like 1. Usually this part of my talk doesn't go very well. But 10 points, that's actually really impressive. Well done. OK. I'm just thinking, have I got anything? No. Do you want another go? All right, shall we see if we can beat the international world high score of Laser Clappy Bird? All right, let's do it. 3, 2, 1, go. Oh. Well, that was great. Nice job, everyone. Excellent. But I think, you know, you deserve a round of applause for getting 10, the world high score of Laser Flappy Bird. Let's hear it, everyone. Nice job. Yes, you were applauding yourselves. Excellent. OK, all right, so I've really become quite obsessed, so I'm going to have to talk more about retro technology, because I'm sort of a bit obsessed by it lately. Now I'm going to talk about the Nintendo, the NES, right? Who had a NES? Was that big here? So yeah, mid to late 80s, pretty cool. Pretty cool game. This is the advert for it. It's pretty amazing. You can get some pretty spectacular peripherals, like the robot assistant. Rubbish. It was absolutely rubbish. But what wasn't rubbish was the zapper gun, right? Anyone play the zapper gun? Pretty impressive. Let's just check out the specs. Wow. Pinpoint accuracy from up to 16 feet. Yeah, that's pretty impressive. Especially like the cable's only 8 feet, right? So I'm not quite sure how that's meant to work. But anyway, that version of the NES came with Mario Brothers and also Duck Hunt. So you probably might recognize Duck Hunts. You have the little dog who jumps over the hedge, scares the ducks away. You've got your Nintendo zapper. You're shooting the ducks. If you hit them, they fall down. That's basically the idea of the game. I got a little bit obsessed, though, with this game. Not when it came out. I never had one when I was young. But just recently, because I've been retro. What can I say? So, but I'm not the only one who was really into it. Everyone loved this game. People there playing it when they were kids. Oh, even dress up their children as the dog from Duck Hunt. Or some enthusiastic adults even dress themselves up. Some really terrifying adults dress up. What the hell is that? I don't even know. So I bought a couple of zapper guns recently. They're pretty cool. I pulled it apart. Do you want to know how they work? Right? It's kind of magic, right? You just point it at your telly. There's no sensors or anything. So anyway, I pulled one apart. You can see there's the insides. So well made, actually. I know it just looks like plastic, but that's just a weight. And that's a weight, too, just to make it feel better. Right? So that's pretty cool. We got a circuit board here, and this is quite a bit more advanced than the circuit board in the 1979 joystick. There's a lot more circuitry on that. So I guess that would have been maybe 7 or 8 years later. We got quite a bit more sophistication. There's also a light sensor in this metal hole here. So you'd think a light gun would shoot out light, but actually it doesn't. It just receives light. So let's just have a look at the game. So you're playing it here. You see the duck fly out. You pull the trigger, makes the noise, and you hit the duck. So what exactly happened there? Well, let's freeze the frame and rewind a little bit. Yeah, special effects. OK, so the duck's flying. You pull the trigger. The computer knows that you pulled the trigger, and the whole screen goes black. Right? So it just happens for one tiny frame. You can't even notice it. But the sensor inside the gun calibrates itself to that black screen. Then you see a white block where the duck was. So if the gun sees black and then white, it knows that it's hit the duck. Right. That's pretty cool, isn't it? So if there are 2 ducks, then it works by flashing first white in where the first duck is, like there. And then it flashes a second time for the second duck. So it knows how much delay there is between you pulling the trigger and seeing the white square. So that's how it knows which duck you've hit. So that's pretty cool. The bad news is it doesn't work on modern TVs. Sad emoji face. They didn't even have emojis in those days. Yeah, we're pretty sophisticated now. So why doesn't it work on modern TVs? Well, it should work, right? But modern TVs have kind of digital processing. There's a tiny bit of latency on the TV. And even if it was only like 20 milliseconds of delay getting the picture onto your TV, then it wouldn't work. The gun wouldn't work. It relies on pinpoint accuracy. If you've got a train to catch, I'm sorry to keep you. You're not missing any of the good bits, it's fine. So yeah, even if there's a tiny bit of latency, it won't work, which is great for me, because it means there's loads of these guns on Amazon. I can pick them up. I've got about 6 now. Because I thought, wouldn't it be cool if I got one of these guns and put a laser in it? Right, so about 24 hours later, I had a laser. That was so easy. I just put a laser in. It was so easy. It was brilliant. But I wasn't really happy with just that. You can see a close-up of the laser here. So not as well as just a laser, I put some super bright LEDs on the outside, like in my light synths. Oh, this wire is doing my head in. Hang on. Just excuse me a moment. Yeah, so super bright LEDs to help just sell that laser effect. But the thing about laser, oh, and also I got a really massive laser. That laser was just from a little laser pointer like this. But I thought, oh, I'm going to need a bigger laser. Because the thing about lasers is you can't really see the laser beams, right? Like this laser pointer, you can't see any of the laser beam there. It's like, where's the laser beam? You know it's there because it comes out at the end, right? But there's no laser beam. The only way you can see laser beams is if there's like smoke or fog. So I thought, wouldn't it be cool to put a smoke machine inside the gun as well, right? So I started experimenting with e-cigarettes. Does anyone vape here? Yeah, vaping is quite weird, isn't it? It's sort of really future-y. I like it, but I sort of like it, and it's also weird. I don't know. I'm confused. But vape machines for making smoke machines are really cool. It was really funny, because I went into the vaping shop, and I was like, I'd like an e-cigarette, please. And they're like, how big would you like? I was like, I don't know. It's really small. It's to go in a laser gun. What flavor would you want? I don't know. No. I don't want flavor. No flavor. Well, they all have flavors. Oh, anyway, they didn't quite get it. But that was the first e-cigarette. But then I found that you can get these tiny e-cigarettes, even smaller. Right? And all you need is a tiny little air pump, and you can pump the air through it, and it makes smoke come out the other side. It's so cool. And the thing I realized is that all the entirety of the smoke machine was just in this little bit here. There's all the liquid in there and the atomizer. The rest of it is just a battery, right? So I thought, well, take that part, sliced it up, and put it in there. And then I also needed to design a custom circuit board to put all the electronics inside. So there's a milled circuit board that powers the laser and the lights. It reads the switch, turns the smoke machine on, the air pump, and I've also put a little fan in there as well. Here's it all together. You can see it's, oh, there you go, the final effects, right? So you can see the smoke's coming out. Now you can see the laser beam. It's cool, isn't it? So much cooler. So this is the final, the final thing, the final insides. So here we have the custom circuit board with an Arduino compatible on there called the Teensy. That is going to the super bright LEDs on the outside. There's a wire going under there to the switch. That's the original micro switch for the trigger. That's the air pump, 3D printed duct into the atomizer there. That's the e-cigarette in there. It's so tiny, it's cool. And that's a little fan to help push the smoke through. And then this is a 3D printed mount. You can see it's got sort of grooves in it. That's so the smoke can get through to the outside. And that, of course, is the big laser. So yeah, that was the first part. But the second part was, well, how can I actually play games with this laser gun? So I needed to be able to figure out where the laser hit the wall. So I set up a camera pointing at the wall, and wherever my laser gun hit it, it would see it. And I realized that what I could do is actually, I could actually track that laser pointer. And so I could actually draw. I could draw with this tiny laser pointer and then render out the shape of where I'd drawn with my big laser. All right, so that's the big laser that you saw earlier. Here's where I write my name, I think. There you go. Seb, yeah, laser graffiti, whoa. So then I thought, well, let's get that working with the gun. So you can see here is just a little test where I fire the gun, and it just it leaves the mark. And then I thought, well, that's not much fun. Why don't I just make a little laser particle explosion? Yeah. That was pretty cool. Yeah, it turns out the internet really likes laser guns because I tweeted that. And that kind of exploded. Gizmodo took it up. A few other Hackaday picked it up as well as Motherboard. So it was pretty popular. And then I installed it. I'd set it up in a space where people could play it. And is that playing? There you go. Oh, people loved it. And this is, this is actually playing Asteroids. You'll see in a moment. So yeah, it was a kind of dual player Asteroid. So one person was controlling the ship, and the other person could help shoot shoot the asteroids. It was, you know, collaborative. But you can see the asteroids there and the laser. Lasers are really hard to video. There's just no choice. I'm going to have to bring one. That's as simple as that. But asteroids is cool, but I thought, wouldn't it be better to have, if I did actual duck hunt, right? So I thought, well, let's just make duck hunts into laser duck hunt. Now, obviously, asteroids is a vector-shaped game, but duck hunt is pixels, so I had to manually redraw all of the sprites, the ducks there, into something the laser could render. So I made laser duck hunts. Unfortunately, I don't have an awful lot of good footage of that, because like I said, lasers, they really kind of, they strobe a lot when you try to film them. But you can see I did the dog, the animation of the dog and the barking and everything. I think there's some sound. It's probably a bit quiet, isn't it? Let's just play that again. Yeah, so you probably can't tell, but that is about, I don't know, it's probably about 8 meters wide. So, oh, that would go great just up on that wall there, right? Yeah? Next time. OK, so let's just take a review of my gun. So this is how it ended up. That's how it is originally. That's how it ended up. OK, so we're nearly at the end of my talk today. But I've seen other speakers before. I know what they do. They give advice and stuff. It's kind of professional and inspiring and useful and shit. And so far, all I've talked about is lasers. It's not really useful. So I've got some advice for you. What is it? Oh yeah, learn new stuff. Yeah, so there's some advice for you. I mean, we all work in technology, right? So there's stuff changing all the time. So I realized, you know, I was doing all these conferences, and I was saying, yeah, I'm learning new stuff. I'm learning lasers. I'm learning C++. I'm learning Canvas. I'm learning everything. And I love learning new stuff. I could hear myself saying, oh, I love learning new stuff. And I was like, you're so full of shit, right? I don't love it. I really hate learning new stuff. Learning new stuff is the hardest thing ever, right? Because it's really hard. Like, and you just feel like a noob. Like, don't you hate feeling like a noob? It's like you write on a forum, oh, I was just having a bit of trouble with this, with this C++. Noob. But what I realized is I hate learning stuff, but I love having learned new stuff. Right? So you go through some hell, you're like a noob for a week or 2 weeks, just push through the noob week. Because then at the end, you're like better than people who haven't learned it, right? You might not be an expert, right? But you'll be better than those other people you hang out that haven't learned it, right? Just be like, and then you can be like, noob. So learn new stuff. Here's another advice. Finish your projects. So who's ever started a personal project at home? Let's just have a look. OK, so leave your hands up if you finished it. Oh, there's a couple of you. OK, but a lot of people put their hands down. That's because finishing projects is really hard. Why is that? Well, the last 10% of a project takes 90% of the time, right? I'm really good at maths, what can I say? But you know, you start a project, it's really exciting, you solve all the problems, you're doing prototypes, like, yeah, prototypes. You got your particles. Is that just my project? I don't know. You've done the particles, you've done your test, it's the fun bit, is over, and then it's just work, right? And then it's like loads of work, and you're like, oh, I've got a job already, and now I've got another job at home. It's like, oh. But, you know, just push through it, right? Because if you finish it, you're better than everyone else, like, because you've actually finished. Here's another advice. no such thing as a natural talent. It just takes work, right? So for every person you see that's like, oh my God, they're so amazing, I can promise you that they work really hard, right? So just, yeah, I think it's really unhelpful to be like, oh, I'm never going to be as good as them. They're so naturally talented. I don't think that's true. I don't know, I might be wrong. But I still think that everyone, if they just work really hard, might be able to do it. And my final piece of advice is there's always someone better than you. Oh, actually, that sounds really bad, doesn't it? OK, so oh, awkward. Hashtag. No, I don't mean that in a bad way, right? But no matter where you get to, there's always going to be someone better at particles than you. There's going to be someone better at lasers than you. There's going to be someone better than CSS. That doesn't mean you're not very good. It means that you're just your version of that really good thing. And you have all your own special things about you. You're just a special snowflake. Oh, my God. Did I actually say that? No, because that is what professional speakers say stuff like, yeah? OK, cool. Well, on that note, that's kind of the end of my talk. Maybe I should stick to the lasers, maybe? I don't know. Anyway, that's my advice to you. Now, before I finish, I should just say if you're interested in this type of thing, I have a podcast called the Creative Coding Podcast. If you don't want to type in the full URL, it's ccpod.co, or just search for it. We talk about all this sort of technology. My co-host, Ian, is a game developer, so he gets lots of indie game designers on there, and it's a lot of fun. But yeah, if you've got any questions, I'm going to be sticking around, so feel free to come and talk to me. Thanks very much, CrankyCon, for having me, and thank you all for listening. It's been a real pleasure. Thank you.